Today's problem, group balls by sequence. Difficulty is medium. You are given an array of positive integers where each element represents the number written on the ith ball. Wait a second, I got to read that again. Each element represents the number written. Oh, okay, okay. So we have an array of some certain number of balls. Each ball has a number written on it. What is the limit on the numbers? So the numbers, the array can be up to 1 million elements. The number on the ball can be between 0 and 10,000. And K, what is K? Okay, we'll get to K. K is between 1 and 1,000. So we get the array and we get a positive integer. K, the task is determine whether it's possible to rearrange all the balls into groups such that each group contains exactly K balls and the numbers in each group are consecutive integers. These examples are really too simple to be useful. This one is like, the default case. Is that what we want to call it? No, like an edge case where the number of elements in the array is not divisible by k, in which case, yeah, of course, you can't divide it into groups of k. Now, this one, we could divide it into 1, 2, and 10, 11. And when I first looked at this, I thought, well, this is the easiest problem that I've ever seen. I mean, all you need to do is sort the array and then start at the beginning, go through it, and see if you can make groups of k consecutive integers. And then it occurred to me that it doesn't say anywhere here that the integers are unique. Okay. It would have been nice to have an example of that, but we don't. But you can see that it's a problem if the integers aren't unique. So let's say we had, and this will be sorted. We've sorted the array, and what we have is 1, 1, 1, 2, 2, 2, 3, 3, 3. So we start at the beginning, 1. Now we're looking for a 2. We look at the next number. It's another 1. Well, we can't use that. We look at the next number. It's another 1. We can't use it. We look at the next number. That's a 2. All right, so we can use that. What's the next number? Well, it's another 2, and then another 2, and finally we'll get to another 3 and figure out that we do have we do have a group of consecutive integers. Now we get to go back to the second one and do it all over again. And so that's going to be, it's going to be a nested loop that gives us an O of n squared runtime, which is not good if you've got a million elements in the array. But potentially you're iterating through large portions of the array because of the consecutive duplicate elements. Okay, so it's not good. How do we get around that? Well, we can get around it by using a map. That would be the Java solution. Use a map. Well, I mean, pretty much every programming language has some some sort of map data structure. We could use a hash map. We could use a tree map. What's the difference? A tree map maintains the keys in sorted order, so that's good for this problem. A hash map doesn't, although you could sort the hash map. The access time on the hash map is better. You'll get O1 methods on the hash map, and you'll get login methods on the tree map. But that should still be fine. What are the expected complexities here? N log n. Okay, well, we are going to do a sort. So let's say, yeah, n log n. And if we're doing log n lookups on every number, yeah, we're still within the constraints. So let's take a look at the code here. All right. So the first thing, as I said, is let's check the length of the array and see, is it divisible by k? Because if it isn't, we can't do it. We'll just return false. Okay. Next, declare TreeMap, and then for each numbered ball in the array, we'll put it in the map. Or I'm sorry, we'll put it in the map. We'll either put it in the map or we'll increment its count in the map. So that's what this is, get or default. If we try to put a number in the map and it's not there, we're going to get the default, which we've said is 0, and add 1. So it goes in there with a count of 1. If it's already in there, we'll get the count and add 1 to it. Okay, I've got a pen here now because I'm thinking it might be helpful to jot a couple of numbers down here. But okay, so we've loaded all of the numbered balls into the count map, and we're going to go into a while loop here while the map is not empty. We would like it to be empty. We would like to be able to match up all of the numbered balls in groups of k. Now, if we can do that, we'll get down here and we'll return true. If we're not able to do it, we'll return false from inside the loop. But okay, so in the example that I used, which was we got 3 1s, 3 2s, and 3 3s. First ball is count key set. The key set, that's all the keys. So that would be 1 2 3. Iterator next. So the first ball is 1. Frequency is the count. How many of those do we have? And the answer is, well, we have 3 of them. So now we're going to loop from 0 to k. I will start out as 0. Current ball equals first ball. First ball is 1 plus I, which is 0. So current ball is going to be 1. If counts does not contain 1, that's actually not the case. Or counts for the current ball is less than the frequency, 3. That is not the case either because we just took it out of there. So that's fine. Counts, put. All right, so what we're going to do is we are going to change the count for the current ball, which is 1. We're going to change it to the current count, which is 3, minus the frequency, which is 3. And we're going to change it to 0. And then we're going to check, is it 0? And in fact, it is. It is 0. And then we will remove the 1 from the count map. All right, now we go, where are we? We've got to go back up to the top of the for loop. I is now going to be 1. Current ball will be first ball. First ball is 1. 1 plus 1. This is now 2. Okay. If 2 is not in the map, but 2 is in the map, and the count for 2 is also 3. It's not less than frequency. So we don't return false. Instead, we come down here and we set the new count for ball number 2 to, let's see, its current count, 3 minus the frequency, which is 3, which is 0, and then we remove the 2 from the map. Okay, good. Back up to the top of the for loop, increment this. We need it to be less than k. What is k? K is 3. I forgot to say that. K is 3. We're trying to pair up we've got 3 1s, 3 2s, 3 3s, and we're trying to pair them up in groups of 3. All right, so that is now 2. Current ball, first ball plus I is 1 plus 2. So we're now looking at 3. Is 3 in the map? Yes. Is the count of the number of 3 balls less than frequency? No, they're both 3. So we go down here and we have used 3 of the 3 balls. So this goes to 0, gets set to 0. We remove it from the map. All right. I think the only part that's not, intuitively obvious maybe is this right here. We're matching these all at once. So if we had, for example, 3 1s, 3 2s, and 2 3s, what we get for our frequency is based on the first ball. So that's a 3. Now, that means if we're able to match consecutive integers, each of those integers should have a count of 3. So if we get down here and find out that the 3 ball only has a count of 2, then we're toast, okay? And we have to return false. All right, so we've matched them all all at once. This is going to get incremented again to 3. It is now no longer less than k, and so we're going to have to go back to the top of the while loop. While counts is not empty. Counts is empty now because we removed 1, 2, and 3. If it wasn't empty, we would go to the next number in the key set, which could be anything greater than 3, and we would repeat the process. That's all I can think to say about it. Let me take the writing off, move this over, and run it. All right, we got a geek bit. Let's go ahead and like the video. Subscribe to the channel. If you do that, then you'll get in your inbox you'll get every new problem of the day right in your inbox. And that's it. See you next time.